Okay, so this is a 6 marking exam, so it wants us to write quite a bit of information. And again, how we approach this is really, really important to help us get the most marks possible. So it's telling us that there's different ways to extract these metals, and it wants us to explain how we get these four in particular, so aluminium, gold, iron, and silver, how we actually obtain those metals. So what I've done is put it gives you a picture of the reactivity series in the question. I've just got a little bit of it here to show you. What it doesn't tell you in there is that carbon sits in the reactivity series here between aluminium and zinc, okay? So because it's in here, we can use this to help us with our reactivity. So let me show you what I mean. Let's deal with the silver and gold first, because they're right at the bottom of the reactivity series. So we can say here that these are not very reactive. They're right at the bottom of the list, therefore they're not very reactive. And that means we find them as pure substances. So we can find gold and silver just as gold and silver. They're not combined with any other element because they're unreactive. And therefore, all we have to do is just mine them and then we can use them. Okay, we don't have to do any processing. If we now pick on iron, that was one that's been listed in there, okay? You can see iron is just below carbon in the reactivity series. So iron would normally, when we mine it, be found as iron oxide. So for me to make the iron from this, I'm going to react it with carbon because carbon is more reactive than iron. So it's going to remove the oxygen to leave me my iron on its own and carbon dioxide forming. Now here, what has taken place is my iron has lost its oxygen, so we say it has been reduced. Okay, so in your answer, you need to talk about the fact that this process of extraction uses carbon because carbon is more reactive than iron. Talk about it being a reduction. And I would even include this equation to show and make that point very clear. The last one is aluminium. Now, if you look where aluminium is actually above carbon in the reactivity series. So that means that carbon will not reduce aluminium oxide in the same way. Let me just show you and remind you what that means. So if we come down here, so if we talk about aluminium oxide, that's the ore that we get our aluminium from. If I react it with carbon, then nothing will happen. There will be no reaction because the aluminium is too reactive. So therefore, how do I do it? What we do is they use electrolysis. Why do you use electrolysis? Because electrolysis has more energy and is able to then extract the aluminium. And what happens during that reaction? So there's my aluminium oxide. We undergo electrolysis using electricity, and that forms aluminium and oxygen. Again, my aluminium here is with oxygen. Now it's not. So this has been reduced, and I can say that and make that clear as well in my response.